All right, we're back with another Ohio State test standard review. Today we are talking about standard 8.G.3, more about transformation, so we're going to get right into it. Question 1. Stella rotates ABCD 90 degrees counterclockwise around the origin. Then she translates the rectangle to the right by K units to create rectangle WXYZ. One side of WXYZ lies on the y-axis. What is the possible value of K? This is a bit of a complicated question, and let's go into why. Because it's talking about rotations, and rotations are easily the most complicated of all the transformations. Um, you just got to try your best to remember the rotation rules. So 90 degrees clockwise, which is the same as 270 counter, has your coordinate of xy becoming y comma negative x. You flip the order and you change the sign. 180 degrees clockwise or 180 degrees counterclockwise, it's the same thing, has xy becoming negative x, negative y, and 270 degrees clockwise or 90 degrees counter has xy becoming negative y comma x, where you flip the order and negate the y. So Stella rotates ABCD 90 degrees counterclockwise. The first thing we have to do is we have to figure out what our new points are. So A, B, C, D. A is at, we go right 1, we go up 1, 2, 3, 4. A is at 1, 4. B is at 2, 4. C is at 1, 2, 1. 2 comma 1, and D is at 1, 1. So if we're going to rotate this 90 degrees counterclockwise, that means our xy now becomes negative yx. So our 1, 4 becomes the negative y, so negative 4 comma 1. Your x stays the same. B, by that same token, becomes negative 4, 2. C becomes negative 1, 2, and D becomes negative 1, 1. So let's graph that. Negative 4, comma 1 is right here. Negative 4, comma 2 is right here. Negative 1, comma 2 is right here. And negative 1, comma 1 is right here. It says this is translated to the right by K units to create WXYZ. One side lies on the y-axis. What's the possible value of K? So you have to move this shape to the right so that one of the sides is on the y-axis. So either this side or this side. Well, the closest way to do it is to take the side closest to the y-axis. So if we're going to make it so this side right here is touching the y-axis, all we're going to do is move it to the right 1 unit. If you shift this over, and I can even show you this, if I can just get rid of that and that. Okay, if you take this shape and you shift it over 1 unit, now your side is laying on the y-axis. So that's all you have to do. You shift it to the right 1 unit. Question 2. The vertices of triangle EFG are negative 3, 4, 5, 2, and negative 6, 1. The vertices of E prime, F prime, G prime are 4, 3, 2, negative 5, and 1, 6. What transformation can map EFG to E prime, F prime, G prime. Okay, so here's the thing. Okay, you'll notice if you look between E and E prime that the order of the numbers changed. The 3 was first here, now it's second here. The 4 was second here, now it's first here. Same thing with F. The 5 was first here, and now it's second here. Same thing with G. The 6 was first here, now it's second here. There is only one transformation that alters the order of X, Y, and that's rotations. So this has to be some sort of rotation. So it's not a reflection, it's not a reflection. It's either a 180-degree rotation or a 90-degree rotation. And one thing you can remember, a 180-degree rotation is the same thing as a reflection over both axes. Meaning that you can do a 180-degree rotation without needing to actually rotate. You can do it by two reflections. XY doesn't change order because you're just doing multiple reflections. If you look up here, 180 degrees clockwise is just XY becomes negative X, negative Y. Okay? So the only option we have left is a 90-degree clockwise rotation around the origin. Do I need to remember what the 90-degree clockwise rotation around the origin rule is? No. And honestly, like I said, the rotation rules are the hardest ones to remember. Do I need to know it for this question? No. I just know that it can't be reflections. And with that knowledge, I can get this. Triangle ABC has vertices 0, 1, 2, 5, and 6, 3. Triangle A prime, B prime, C prime is created by reflecting triangle ABC over the y-axis. What is the x-coordinate of vertex C? So, we're working with point C. We have to work with point C. Reflections are, in my opinion, probably the easiest transformation to do with when you just have to figure out how to change the coordinate. No, maybe translations. But if you're reflecting over the x-axis, which I'm going to denote by Rx, your xy becomes x negative y. If you're reflecting over the y-axis, your xy becomes negative x, comma y. You just negate the other letter. So, reflect over x, you negate y. Reflect over y, you negate x. The hint to this is that they specifically ask you, what is the x-coordinate of vertex C? Okay? If they wanted to try to trick you, they would ask you for the whole coordinate, and that could be tricky if you don't remember the rule. But the fact that they're giving you the x, that they're saying they want only the x-coordinate, means that the x-coordinate is more than likely the one that's going to change. So if your point is 6, 3, and you reflect it over y, then it becomes negative x, comma y, so it becomes negative 6, comma 3. Your answer is just negative 6. And that's it. Rectangle MNOP is shown. It is then translated 3 units down. What are the coordinates of P prime? All right, so all you're going to do is you're going to find P. And you're going to determine what point P is. Well, to get to point P, we have to go 1, 2, 3, 4 to the left, up 1. So we know that P is negative 4, comma 1. And all you're going to do is you're going to move that down 3 spots. 1, 2, 3. You move it down 3. And now your new point is negative 4, comma, negative 2. Just move it down. That's your answer. All right. 2 triangles, JKL and MNO, are shown. What transformation can be applied to JKL to create MNO? All right. So, remember here that the order that the letters are listed matters. Okay? So J and M are tied together. So this would be M. K and N are tied together, so this could be N. And L and O are tied together, so this could be O. Okay? So now, knowing this, we know that J is at negative 4 comma 1. J is at negative 4 comma 1. And our new point M is at 4 comma negative 1. K is at 1, 2, 3, 4, 5, 1, 2, 3, negative 5 comma 3. We went left 5, up 3. K's new point is attached to N, 1, 2, 3, 4, 5, down 1, 2, 3. Okay? Oh, 5, comma negative 3. Okay? L is left 2, up 4, so that is negative 2 comma 4. And its new coordinate with O is right 2, down 4. So 2 comma negative 4. So all we did was we switched the signs of both X and Y. We switched the signs of both X and Y. We switched the signs of both X and Y. Which of these choices involves switching the signs of both X and Y? It is a clockwise rotation of 180 degrees, as evidenced by our rule up here, where xy becomes negative x, negative y. All right. Triangle QRS is located on the coordinate plane, where vertex Q is located at the point AB. The triangle is reflected across the x-axis and then translated 2 units to the right to create triangle TUV. Create an expression for the x-coordinate of t. Okay? So Q is at AB. So your coordinate is A, right? Your x-coordinate. So we should have A. It's reflected across the x-axis and then translated 2 units to the right. Does reflecting change the x-coordinate? No, it doesn't. It changes only the y-coordinate. So it is then translated 2 units to the right. Okay? So you're just adding 2. So picture this. If instead of it being AB, let's say that Q is on, 1, 1. Okay? When you reflect it over the x-axis, your new point will become 1, negative 1. And then to move it to the right 2 units, you add 2 to your x. So your new point will be 3, negative 1. So whatever your starting value was, plus 2. A plus 2. That's it. A figure is shown. This figure is reflected across line L. What figure is the best result of this transformation? So this is a reflection over what is essentially the y-axis. They just called it line L because it's funny. Okay? So remember when we talked about reflections, if you watch the first transformations video, and we talked about reflections, I said the point that was closest to the axis that you're reflecting over would be the points that are closest to the axis after reflection. Okay? So the points that are farthest away will be the points farthest away. So your line will just look something, albeit I'm a terrible artist, but like this. Our points that are the closest are also the closest. Our points that are the farthest are also the farthest. So which one looks like that? A. All right, so that's going to wrap up this standard. I'll be back for another standard. Until then, thanks for watching and good luck on your state test.